Okay, dear students, today we are going to discuss exercise 5, division of integers. Exercise 5 depends on division of integers. Some points are given, let us see. Division is the inverse operation of multiplication. Both are opposite to each other. Okay, when we divide a negative integer by a positive integer or positive integer by a negative integer, we divide them as a whole number and then a negative sign for the quotient. We thus get a negative integer as the quotient. Simply I will write here, see, plus divided by plus, you will get plus. Plus divided by plus is equal to plus you will get. Okay, a little bit right side I will write. Plus divided by plus is equal to plus. Minus divided by minus, you will get plus. Plus divided by minus, plus divided by minus, minus you will get. Minus divided by plus, you will get minus. Plus divided by plus is equal to plus. Minus divided by minus is equal to plus. Plus by minus or minus by plus. In both the cases you will get a minus. Okay, that is the thing you have to remember. Next, here see, do this. First one, compute the following. Compute the following. First one, minus 100 divided by 5. Minus 100 divided by 5. Here you have to understand minus divided by plus. Nothing is there means plus. Minus by plus. Minus by plus is equal to, you will get minus first of all. Minus 100 by 5. How many times it goes? 20 times it goes. So minus 20 is the answer. Minus 20. Now let us see the second question. Minus 81 divided by 9. Minus 81 divided by 9. So minus by plus. Again minus by plus. You will get minus. Here how many times? 9 9s are 81. 9 9s are 81. Okay, next third question. Minus 75. Minus 75 by 5. Minus 75 by 5. So minus by plus is equal to minus 5. 15 times it goes. 15 times it goes. Okay. Next. Minus 32 by 2. Fourth one. Minus 32 by 2. So this is equal to, here also same. Minus by plus. So minus. How many times goes means 16 times it goes. Okay. Next. Fifth one. 125 divided by minus 25. 125 divided by minus 25. Here see, this can be written as 125 divided by minus 25. So in all the cases to the numerator we have seen. Here to the denominator. Plus divided by minus. Plus divided by minus. Here see, plus by minus. You will get minus. So minus. How many times goes? 5. 5 times goes. 25. 5 times. Okay, 5 times. So 525 are 125. So minus 5 is the answer. Now let us see sixth one. 80 divided by minus 5. 80 divided by minus 5. Here 5 16 times goes. Plus by minus. Plus by minus is equal to minus. So minus 16 is the answer. Now seventh question. Seventh question. Let us see seventh question. 64 divided by minus 16. 64 divided by minus 16. Here see, plus by minus. Plus by minus. Minus you will get. 16 how many times goes? 4 times. 4 16s are 24. Or 64. Okay. 4 16s are 64. That's all. Okay. Here also one conclusion is given. We can say that when we divide a negative integer by a negative integer, we get a positive as the quotient. Here see, already we have written that one. Negative integer by negative integer, you will get a positive quotient. Okay. Some examples also given. Let us try to solve those examples. First one, minus 36 by minus 4. Minus 36 by minus 4. First one, here see, minus 36 by minus 4. This is equal to minus by minus. Minus by minus. Minus by minus. Plus you will get. Okay, plus 6 how many times goes? 9 times. 9 fours are 32. Next, the second one. Minus 201 by minus 3. Minus 201 by minus 3. Here minus by minus, plus you will get 3 how many times goes? 6 3s are 18. Okay, 6 3s are 18. 6 times goes. Next 2 is there, 21. 7 3s are 67 times it goes. 67 3s are 201. Next, third one. Let us see third one. Minus 325 divided by minus 13. Minus 325 by minus 13. Minus divided by minus. Here see minus by minus, plus you will get. So plus how many times it goes? 2 13s are 26. Here see 325. Okay, 13 table. 2 13s are 26. 3 13s are 39. It becomes more. So 2 times only we will take. 12 minus 6, 6. 2 minus 2, 0. No need to write. Again, 5 get down. How many times? 13 5s are 65. So remainder 0. Total 25 times. So what is the answer? 25 is the answer. Okay now? Right. So minus by minus you will get plus. Here see properties of integers. Properties of integers we have to learn. What are the properties? Here see closure property is given. Closure property. What is the meaning of closure property? Here see properties of integers, closure property under addition. Under addition. Here see there are 4 operations. Addition operation is there. Next, subtraction operation is there. Multiplication operation is there. Division operation is there. 4 operations are there. Which operation we are taking? That one also we have to consider. And what is the property? Closure property under addition. Closure property under subtraction. Closure property under multiplication. Closure property under division. Like that all these things we will see. What are given? Let us see those things. Suppose the second one, associative property. Associative property under addition. Associative property under subtraction. Associative property under multiplication. Like that we will see what are the things given here. Okay. See first one, closure property under addition. Closure property. Closure property. Closure property under addition. So plus you have to consider here. So what is the meaning of a closure property? Here integers means, suppose integers, a set of integers, it is denoted by z. Z is equal to set of so on minus 3, minus 2, minus 1, 0, 1, 2, 3, so on. So on minus 3, minus 2, minus 1, 0, 1, 2, 3, so on. If you take any 2 integers, let us take 2 integers. Suppose 2 comma 3. Let us take 2 comma 3. 2 plus 3 is equal to 5. 5 is an integer. 5 is also an integer, no? While we are writing 4, 5, 6 like that. Again we got the same in the same set. Okay. Whenever you add 2 integers, you got another integer. That means integer plus integer is equal to, again you got integer. Integer plus integer you got again integer. Yes or no? So this type of property is called as a closure property. Whenever you add 2 integers, again if you get integer, then we say that the set of integers follows closure property under addition. Addition operation we have taken here, addition. Yes or no? Next, suppose if you take these two, minus 2 plus minus 1. So this is equal to totally minus 2 minus 1 minus 3. Again this is also an integer. Here minus 3 is there, integer. Therefore here also integer plus integer is equal to integer you got. Yes or no? So in general, suppose if A and B are 2 integers, this symbol is called belongs to. This symbol belongs to, you have to read. Belongs to means that is an element in that set. So suppose here you write 2 belongs to Z. 2 is an element, 2 is a number in set Z. Okay. Next, suppose minus 2 is an element in set Z. Like that we have to use. If A and B are 2 integers in set Z, then suppose if A plus B also belongs to Z, A plus B also belongs to Z, then we say that the set of integers follows closure property under addition. Okay. Here see what is given, let us see. In general, for any 2 integers A and B, A plus B is also an integer. A plus B is also an integer, you have to remember. Next, commutative property, commutative. This is also called as abelian property. Commutative property is also called as abelian property. Same set, same operation, but property is different. Let us see what is that property. Okay, commutative. Operation is the same. Okay, addition only. Commutative. Commutative property. Commutative property means under addition means suppose if you take 2 plus 3 or suppose 4, 5, 6 so on. Let us take 5 comma 6. 5 comma 6 belongs to Z. 5 and 6 are elements in the set Z. Operation we have to take down plus. So first find 5 plus 6. 5 plus 6 you will get 11. And again find 6 plus 5. Reverse, I changed the order, 5 plus 6, here 6 plus 5, same answer I got. Therefore, 5 plus 6 is equal to 6 plus 5. Same answer we are getting, 5 plus 6 is equal to 6 plus 5. Hence, we say that the set Z follows commutative property under addition, okay. Suppose if you take negative numbers, minus 1 plus minus 4. So, this is equal to minus 1 plus into minus, minus 4. Minus 5 you will get. Reverse, minus 4 plus minus 1. Minus 4 plus into minus, minus 1. Minus 5. Same answer, even though we changed the order. Therefore, we say that minus 1 plus minus 4 is equal to, minus 1 plus minus 4 is equal to minus 4 plus minus 1. Therefore, we say that the set Z follows commutative property under addition. Suppose if you take one positive and a negative integer, suppose 3 comma minus 1. 3 comma minus 1. So first of all, let us see 3 plus minus 1. So this is equal to 3 plus into minus minus 1. 2 you will get. Okay. Next reverse the order. Minus 1 plus 3. Let us see. Minus 1 plus 3 means this is also 3 minus 1. This is also 2. Therefore, we say that 3 plus minus 1 is equal to minus 1 plus 3. Even though we changed the order, we got the same answer. So, in general, how do we write means, suppose A comma B belongs to Z. A and B are two elements in the set integers, okay, integers set. So, A, B belongs to Z. If A plus B is equal to B plus A, if A plus B is equal to B plus A, then we say that the set Z follows commutative property under addition. What is the operation we have taken? That is also important. Okay. Next, that is commutative property. In general, see here, in general, for any two integers A and B, A plus B is equal to B plus A. Okay. Next, associative property. Let us see associative property. Here we have to take down three integers. Okay, associative property. Associative property. Associative property. What is the meaning of associative property means? Here we have to take down three numbers. A, B, C belongs to Z. Under addition operation we have to do. See, first of all, we have to add A plus B. A and B we have to add A plus B and then add C. First you add A and B and then add C to the result, A plus B plus C. If this is equal to A plus B plus C. So first you add B plus C and then add A to B plus C. Then you will get like this. See how to read this means A plus B plus C. After this one just give a break. A plus B plus C is equal to A plus B plus C. A plus B plus C is equal to A plus B plus C. Like that you have to read. Okay. So if it is happens, okay, then we say that the set of integers follows associative property under addition. Okay, under addition we have to say. So let us see some examples. Same examples, suppose 2, 3, 4 or 2, 3 minus 1. 2, 3 minus 1. Okay. See, first of all, we add these two, 2 plus 3, okay, 2 plus 3 plus minus 1. This is equal to 2 plus 3 value 5 plus into minus minus. 5 minus 1 is equal to 4. Now 2 plus 3 plus minus 1. Here see, first of all you have to do this and then add this one. Here first of all I have done this and then added this one. Okay, first I added these two things and then add minus 1. I got 4. Now I add 3 and minus 1 first and then add 2 to the result. So this is equal to 2 plus this is 3 minus 1 plus into minus minus 3 minus 1. So 2 plus 3 minus 1 value 2. 2 plus 2 4. The same answer I got. Even though I changed the order of addition, I got the same answer. Therefore, the set of integers follows associative property under addition. See, in general we write a, b, c are any three integers in the set z. A plus b plus c is equal to a plus b plus c. Okay, a plus b plus c. This is associative property. Next, additive identity. Additive identity means you have to remember, suppose if you take a number, if you take an integer, let us take an integer. Additive identity, very very important. This is additive identity. Additive identity. Suppose I take 3. 3 plus dash is equal to 3. Next I take 5. 5 plus dash is equal to 5. I take minus 3. Minus 3 plus dash is equal to minus 3. Is there any integer which satisfies these rules? Suppose if I write 1 here, then 3 plus 1 is equal to 4. So I should not write 1. Suppose if I write 2 here, 3 plus 2 is equal to, it becomes 5. So I should not write 2 here. If I write 0, 3 plus 0 is equal to 3. Yes, well satisfied. 5 plus 0 is equal to 5. Minus 3 plus 0 is equal to minus 3. So 0 is there, no? 0. Whenever we are adding 0, the same answer we are getting. Whenever we add 0, the same answer. Here 3 is there, 3 plus 0, same 3 we got. 5 is 0, 5 plus 0, 5, same answer we got. Minus 3 plus 0, minus 3, same answer we got. Yes or no? So like this, you have to understand. Okay. So 0 is an integer or not an integer? 0 is an integer. Here see, 0 is there, neither positive nor negative. Neither positive integer nor negative integer, but it is an integer, 0. Such type of integer is there. So additive identity, this is called as additive identity. Okay, so this is called as additive identity. In general here see, a plus 0 is equal to 0 plus a is equal to a. So the set Z has additive identity over addition. That means with respect to addition operation, here we are doing additions only. Yes or no? So this is called as additive identity. Additive identity 0 you have to remember. Next here see additive inverse. Additive inverse also you have to understand. Additive inverse. Additive inverse means nothing is there. Very simple. See additive inverse. Additive inverse. Suppose here see 3 plus dash is equal to 0. Additive identity, I have to get additive identity. Okay. Next, minus 2 plus dash is equal to 0. Minus 3 plus dash is equal to 0. What I have to write here to get 0? Minus 3. Is there minus 3 in Z? Yes, minus 3 is there in Z. Minus 2, what I have to write? 2. Minus 2 plus 2 cancel, 0 you will get. Is there 2 in Z? Yes, 2 is there in Z. Minus 3 plus what I have to write? 3. Both are cancelled, 0. 3 is there in Z? Yes, there is 3 in Z. In such a way, here see, if the sum of two numbers is 0, then each one is called additive inverse of the other. Every number is the additive inverse of the other number. Okay. Suppose here see, 3 is the additive inverse of minus 3. 3 is the additive inverse of minus 3. Minus 3 is the additive inverse of 3. Minus 3 is the additive inverse of 3. So in such a way, here see, a plus b is equal to 0. Suppose a plus b is equal to 0, then a plus b is equal to 0, then a is equal to minus b. A is equal to minus b. If sum of two numbers is 0, then b is the additive inverse of a is the additive inverse of b. A is the additive inverse of b. Here see, in general for any integer a, there exists an integer minus a, such that suppose if a number 3 is given to you, what is the additive inverse means? Minus 3. You have to multiply with minus. Suppose minus 3 I gave you. What is the additive inverse means? Minus of minus 3, that is equal to plus 3. Plus 3 is the additive inverse. You have to understand. Okay. Both the integers are called additive inverse of each other. So 3 is the additive inverse of minus 3. Minus 3 is the additive inverse of plus 3. Okay. Next, here see, properties of integers under multiplication. See, properties of integers we have seen under addition. Under addition we have seen. Now properties of integers under multiplication. Properties of integers under multiplication we have to check it. Now operation we have to take down is multiplication. We have to take down multiplication operation. We have to take down. The set is the same set we have been taken. Here see, first closure property. Closure property. Now operation is multiplication. Closure property and operation is multiplication. Okay. Again I will write z. Z is equal to set of so on minus 3, minus 2, minus 1, 0, 1, 2, 3, so on. Now multiplication. Suppose let us take two integers. Suppose minus 2 and 3. Okay. Minus 2 comma 3 belongs to z. Minus 2 and 3 are two integers. Now multiply them. In the previous case we added them. Because of under addition we have done. Now we have to multiply them. Because of under multiplication, operation is multiplication. Therefore 2 minus 2 into 3, let us take 2 3s are 6, minus into plus minus, we got minus 6. Minus 6 also is an integer. While we are writing minus 4, minus 5, next minus 6 will come. This is also an integer. Okay, belongs to z. Next, suppose anything. Suppose 2 into 3, 2 3s are 6, that is also belongs to z. So in general, if a and b are two integers, then their multiplication a into b, that means ab also belongs to z. Whenever we multiply two integers, you will get again integer. Okay, this is called as closure property under multiplication. Okay, see, in general, if a and b are two integers, a into b is also an integer. Next, here see, multiply the following. 2 into 3, 6 is an integer. 5 into 4, 20, 5 4s are 20, 20 also an integer. 3 into 6, 3 6s are 18, that is also an integer. Similarly, multiply any two whole numbers of your choice. Is the product of two whole numbers is always a whole number? Yes, whole numbers if you take whole number set, W is equal to set of 0, 1, 2, 3, so on. These are whole numbers. If you take any two whole numbers, suppose 2 into 3, 6, that is a whole number. Suppose 5 into 6, 30 also whole number. So multiplication of two whole numbers is also again a whole number. Okay. Next, commutative property under multiplication. Okay, commutative property under multiplication. Commutative property under multiplication. Commutative. Commutative property means here see, in the last case we have seen a plus b is equal to b plus a, that is commutative property. Now under multiplication, therefore a into b is equal to b into a. If it happens, it follows a commutative property, simply we say. Okay. Now let us take minus 1 and 2. Suppose minus 1 into 2 is equal to minus 2. 2 ones are 2, minus is there, so minus 2. Now again reverse, 2 into minus 1, 2 into minus 1, minus 2, same answer we got. Therefore simply we say that minus 1 into 2 is equal to 2 into minus 1. In general, how do we say, means if a comma b belongs to Z, a and b are two integers, then a into b is equal to b into a. This is called as commutative property under multiplication. Therefore the set of integers follow commutative property under multiplication, okay. Now associative property, here see, the product of three integers does not depend upon the grouping of integers. Therefore multiplication of integers is also associative. It means that, I will explain. Let us see. Okay dear students, associative property. Now let us take associative property. Associative property means let us take here 3, 4, here 4 is there, no, 4, 5 and so on. 2, 3, 4, 2, 3, 4 belongs to Z. Let us take 2, 3, 4 belongs to Z. Now first you multiply 2 into 3. So 2 into 3, here see, into 4 also I have been taking. First you multiply 2 into 3. 2 3s are 6 into 4. Final answer is 24. Now here 2 into 3 into 4. 2 into 3 into 4. This is equal to 2 into 3 into 4. 3 4s are 12. Again the same answer we got. So that is the thing he has said. The product of three integers does not depend upon the grouping of integers. Here we grouped these two. Here we grouped these two. So this final product does not depend on this grouping. So this is called as associative property. In general, suppose A, B, C belongs to Z. A, B, C are any three integers. Then A into B into C is equal to A into B into C. A into B into C. This is called as associative property of integers under multiplication. A into B into C is equal to A into B into C. A into B into C. Okay, that one you have to remember. This is called associative property. Okay, next, do this is given. Let us check it. Okay, do this. Depend on the associative property. Let us try to solve that one. Here see, first one minus 5 into 2 minus 5 into 2 is into 3. Okay. Minus 5 into 2 into 3 is equal to minus 5 into 2 into 3. This is the question. First LHS let us find. LHS value. LHS is equal to minus 5 into 2, or directly we can do here. ikkade cheseddamandi. Here see, 5 into 2 10, minus into plus minus 10 into 3 is equal to, here see, minus 5 into 2 3s are 6. So this is equal to 3 into 10, 30, minus is there, minus 30. 6 5s are 30, minus is there, minus 30. Same answer we got. Is this one is equal to that one, means yes, that is. Okay. Next, second one also, let us see second one. What is the second one? Is minus 2 into 6 minus 2 into 6 into 4 is equal to minus 2 into 6 into 6 into 4. Now here see, minus 2 into 6, minus 12 into 4 is equal to, here minus 2 into 6 fours are 24, 12 fours are 48, minus is there, so minus 48, 2 24s are 48, minus 48, both are same. So the multiplication does not depend on grouping. Here left side these two values are grouped, on the right side these two values are grouped, even then we got the same answer. Okay, now here see, try this, 5 into 2 into 3, 5 into 2 into 3 is equal to 5 into 2 into 3, 5 into 2 into 3 is equal to 5 into 2 into 3, 5 2s are 10 into 3 is equal to 5 into 2 3s are 6, 10 3s are 30 is equal to 5 6s are 30. So is the associative property true for whole numbers? Yes, in the case of whole numbers also it is true, because of these are also whole numbers. Yes or no? Okay, next let us see distributive property. Distributive property. What is the distributive property? Here see, in general for any integers a, b, c, three integers given a, b, c, a into b plus c is equal to ab plus ac. Okay, so now distributive property. Distributive property. Okay, distributive property. If a, b, c belongs to z, a comma b comma c belongs to z, then a plus a into b plus c is equal to, first a into b, ab, plus a into c, ac, ab plus ac, or this can be written as ఇలా కూడా రాసుకోవచ్చు, a into b plus c is equal to a into b plus a into c. So this is called as a distributive property. Left distributive it is, because from left side we are multiplying. Okay, so this is called as distributive property. Here see, one example is given. What is that? Minus 2 into 1 plus 3 is equal to minus 2 into 1 plus minus 2 into 3. That is an example. Next, multiplicative identity. Already we have seen additive identity. In the last case, additive identity we have seen. To explain multiplicative identity, I will write some examples here. Multiplicative identity. Multiplicative identity. 3 into dash is equal to 3. 4 into dash is equal to 4. Minus 1 into dash is equal to minus 1. Okay, so what number should we write here to get the same answer? Suppose if you write 1,